Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all. My name is Muhammad Afiq bin HAZMI 2200160, and my fellow friends Faris, AIMAN, NAIM, and TING will be presenting about application of fluid mechanics in ocean thermal energy conversion, which we call OTEC. So let's proceed. So these are the table contents of the information given for today, and let's proceed. Right, the introduction and importance of OTEC. Moving on to the introduction. Ocean thermal energy conversion, or OTEC, is a process or technology for producing energy by harnessing the temperature difference between ocean surface heated by the energy of the sun and the depth of the ocean. So we have three type of OTEC, which are the closed cycle, the open cycle, and the hybrid. The closed cycle, which use ammonia as a working fluid, and open cycle, which use only the water inside the turbine that will be reheated throughout the Rankine cycle. And the third one is the hybrid, which combine both closed and open cycle. So next is the importance of OTEC. We do know that the OTEC temperature difference needed the surface layer and the deeper layers to be around 1000 meter. So it's also generally operating with a temperature difference of 20 degrees Celsius. So, as generally scientists around the world are predicting the ill effects of global warming and its consequences on the mankind. So it's the conventional fuel-fired electric power stations contribute nearly to 21.3% of the global greenhouse gas emission annually. Hence, we found that we need to have an alternative renewable energy conversion, a new type of conversion that can give a cleaner and greener environment. So we choose OTEC. There are a lot more renewable energy, but OTEC is one of them. Um, then we have been designing. I mean, not we. They have been designing 5 megawatt of OTEC pre-commercially, and plan is clearly to portray to brief the OTEC technical feasibility along with economic consideration studies for installing OTEC across the world. With OTEC, practically for every megawatt of power generated by hybrid OTEC, nearly 2.28 million liters of desalinated water are produced, which are fresh water, also the side effect of OTEC.
Assalamualaikum and hi, I am 2200169 Faris bin HANAPI, and I will be talking about basic operation theory of OTEC. First thing first, in OTEC, no fuel is burned because a temperature gradient already exists in the ocean, so there is no need to artificially create one by burning fuel. Instead, we use the temperature difference between the hot ocean surface and the cooler deeper layers beneath to drive a heat engine in a broadly similar manner. We need the largest vertical temperature gradient we can discover, as the temperature differential is very crucial. In actuality, that implies a location where the deep waters are as cold as they can be and the top waters are as hot as we can discover. So in a closed cycle OTEC, there's a long closed loop of pipeline filled with a fluid such as ammonia, which has a very low boiling point. First, the pipe flow through a heat exchanger fixed in the hot surface water of the ocean, which makes the ammonia boil and vaporize. The heated ammonia vapor expands and blow through a turbine, which extracts some of its energy, driving a generator to produce electricity. Once the ammonia has expanded, it passes through a second heat exchanger where cool water pumped up from the ocean depth condenses it back to a liquid so it can be recycled. In OTEC, the ammonia picks up heat from the hot surface ocean water, carries it to the turbine where much of its energy is extracted, and is then condensed back to a liquid so it can run around the loop for more heat. Next up, advantages and disadvantages of OTEC. So first thing first, it is obviously a renewable energy. OTEC is among the various green energy sources that are gaining in presence in some countries worldwide. Next up, it is a clean energy. Nowadays, we might notice that many countries are trying to go green, which that doesn't apply to just tree planting, but also to electrical power production. Next up, it is a reliable sources, and fresh water is created. For every 1000 liter of water, there is processed in the OTEC process, 5 liters of fresh water is created. Next up, it is environmentally friendly. The ocean thermal energy plants are mainly situated in the sea and away from the human settlements. This makes sure that there is no interaction among the dense human population on the land and the energy plant. Next, it is a low maintenance, independent of water, and large amount of solar energy is stored in oceans. Next up, disadvantages of OTEC. The first thing, the locality of production. Just as with other energy generation technique, we know many suitable places for this energy harnessing. This is a disadvantageous to some countries with a coastal line or even landlocked nation. The second one is a high commencing cost. We can see that the price to obtain and fix the required devices for controlling OTEC is relatively high. And the third one interfere with navigation. Next, slight temperature differences. The discrepancy in temperature between surface water and deep water might be small, so this may generate electric energy with moderate efficiency. Next, large size turbines with expensive liquid and harmful on marine life. And that's all from me. Thank you.
Hi, I'm 2200143. Thank you for today. I'm going to talk about the related theory of the OTEC. First, I will talk about the related theory of closed cycle OTEC, and the working principles are at the left side of the slide. And the working fluid used are the ammonia, and disadvantage of the closed cycle system are the quality of working fluid and possibility of biofilling of heat exchanger are the downside of the closed cycle OTEC. Next, I will talk about the related theory of the open cycle OTEC. The working principles are at the right side of the slide, and the components involved are the water vapor, warm seawater, vacuum pump, cold seawater, generator, freshwater output, condenser, and mixed discharge. Next is the formula for the calculation of the flow rate of seawater, which is Q equal to P over efficiency. The efficiency rho Cp theta T, and disadvantage of closed cycle open cycle system are they are susceptible to air in leakage and stimulate the formation of non-condensable gases when operating under partial vacuum circumstances. Therefore, energy is required to pressurize and eliminate these gases. In addition, the low steam density necessitates a higher volumetric flow rate to generate 1 unit of energy. Next are the related theory of hybrid cycle OTEC, and the working principles are at the left side of the slide. And next, I will talk about the thermodynamic process of OTEC system, and this is the Rankine cycle at the right side of the slide. The cycle flow in the operation of tailpipe will be put in the ocean to absorb the sea heat and transport it to a heating tank in order to boil the working fluid. Volatile ammonia is often employed as a working fluid. The fluid vapor will subsequently be used to drive turbines that generate electricity. The fluid vapor is then introduced into the condenser chamber, where it is cooled with 5 degrees Celsius of seawater. The cooled seawater is then discharged back into the ocean, and the cycle will continue. Next are the 6 formula that will be involved in the calculation of the OTEC system. The first one is the calculation of the relationship between the pressure, which is PV equal over T equal to NR and equal to constant. Next is the formula number 2 is the formula to the calculation of work done by the pump, which is W equal to V bracket P1 minus P2, and the third formula is the calculation for the pump efficiency, fluid enthalpy before pumping and after pumping. And H2 equal to H1 minus W over net efficiency, and formula number 4 is the temperature before enter the evaporator, which is TW equal to TC plus W or bracket 1 minus 1 over net efficiency over CH, where CH is the specific heat of seawater. And formula number 5 is the calculation of the total power of cold and warm seawater pumps, P top, and can be formulated as P top equal to 1 bracket 9.8 QF LV square over T2G. And the last formula is the calculation of the gross electrical power, which is PG equal to 3 rho CS QCW and gamma epsilon TB theta T square over 16 bracket 1 plus gamma TW. And the right side of the slide is the picture of the surface seawater temperature and deep sea water temperature difference. That's all from me. Thank you.
Hi and Assalamualaikum. I'm 22000009 Muhammad Daimahiri bin Harun. Would like to present about available design and specification for OTEC. For the first design, we have Okinawa OTEC demonstration facility in Japan. Introduction to these facilities begin with a slide presentation by Mr. Benjamin. The OTEC experimental facilities consist of computer control room, 100 kW OTEC demonstration plant, desalination demo unit, electrical and manual control room. The 100 kW OTEC demonstration plant consists of two units, double Rankine cycle, which are Unit A and Unit B. The working fluid used in this OTEC plant is R134A, hydrofluorocarbon. For the specification, the status of this OTEC is still active. It can generate 100 kilowatts power. The area cover is around 63.5 km. It uses working fluid R134A. The type is closed cycle or double Rankine onshore, and it located at Kumejima, Okinawa, Japan. For the further analysis, you can check out this website below. For the second design is Makai OTEC power plant in Hawaii. Makai Ocean Engineering Ocean Thermal Energy Conversion Power Plant in the US is the world's biggest operational facility of its kind with an annual power generation capacity of 100 kW. For the technology, the OTEC uses the temperature difference between the cold water in the deep sea, 5 degrees, and the warm surface seawater, 25 degrees, to generate clean and renewable electricity. The large amount of deep cool seawater and the warm surface seawater are pumped to run a power cycle to produce electricity. For the specification, Makai OTEC plant is a closed cycle facility that uses an ammonia fluid to drive the turbine generator. The deep seawater is often using either a 40-inch diameter intake pipeline or a 55-inch diameter pipeline. The pipes can supply up to 26,000 gallons a minute of cool seawater, equivalent to warm surface water pump for the facility is minute. The two heat exchangers have a 2 megawatt thermal duty each, are between 2 and 8 meter tall, and have a typical design seawater flow of 0.25 meter cube a second, equivalent to 4,000 gallons a minute. For the last design is Hainan OTEC in China. In detail, the tropical Hainan offshore was identified as an ideal location for the OTEC plant. The plant will be configured as a closed cycle OTEC system. For the specification, the type is closed cycle ocean thermal energy conversion pilot power plant. The location of the coast of Hainan Island in southern China. The developers are Lockheed Martin and Rainwood Group. The capacity is 10 megawatt and it started construction in 2014.
Lastly, the conclusions. Energy is very important for almost all activities in human life. To avoid energy crisis from the limited energy in nature, we use renewable energy, which is OTEC and all sort of other stuff. There are three OTEC that we have learned, which is closed cycle, open cycle, and hybrid system. So OTEC is not only a fantastic way to generate electricity, but it can also produce desalinated seawater and provide cold water for air conditioning and provide nutrient-rich water for marine culture. So there are several ways we can recommend to improve the OTEC system, which is more advanced Rankine cycle, and we can also improve our working fluid. We can also improve our location point, and that's it from us. Thank you.